Welcome to This Explainer. We're diving straight into a massive paradigm shift today, so buckle up. The landscape of artificial intelligence is fundamentally shifting beneath our feet. We are officially entering the age of agency. Now, for years, we've focused on AI that generates text or classifies data, but suddenly we're building systems that can reason, plan, use tools, and take actual actions. And here is the profound reality for any leader deploying advanced AI today. An agent's effectiveness is no longer just going to depend on how much data it's absorbed. It will depend entirely on the depth of the world it constructs internally. So I want you to really think about this. What kind of world is your AI internally constructing? Because as AI moves beyond just answering our questions and actually starts acting on our behalf in the real world, it needs a much deeper architecture. To understand exactly where this is all headed, we're going to explore 3 totally original world models developed by researcher Pravir Malik. These models trace an absolutely incredible journey, starting from human systems, moving to the emergence of meaning, and finally going all the way down to the quantum substrate of reality itself. Here is our roadmap for this strategic briefing. 1. The age of agentic AI. 2. Model 1. Human systems. 3. Model 2. Cosmological emergence. 4. Rewiring LLM attention. 5. Model 3, quantum reality. And 6, property programmed matter. To set the stage, let's look at the macro trend. AI has evolved through some very distinct eras. In the past, we had classification, recognizing images or sorting data. Right now, we're living through the generation era, producing text, code, images. But we're rapidly entering this exciting emerging era of agency, where AI systems actually coordinate complex workflows. And ultimately, this leads to the future era of participation. In this future, AI won't just observe from the outside, it will actively participate in and even shape our physical and human systems. All right, kicking things off with Section 1, the age of agentic AI. You see, there's a massive distinction between a capable tool and a responsible agent. Why do agents actually need these deep world models? Well, because an agent without a deep model might maximize efficiency at the expense of literally everything else. Imagine an AI told to optimize a supply chain. Without a model of nested causality and human consequence, it might accidentally destroy supplier trust or create ecological instability just to hit a metric. To operate responsibly in complex human workflows, AI must be able to distinguish between simply executing a localized task and actually driving true systemic progress. Moving right along to Section 2, Model 1, Human Systems. The first model, the fractal ladder, is all about what we can call organizational DNA. It proposes that the exact same fundamental patterns of development recur across multiple levels of organization. An individual, a corporate team, a global economy, or even a whole civilization, they're all expressions of common building blocks. By giving an AI this model, we're basically teaching it to recognize these repeating structures. So if an AI is advising a CEO, it won't just stare at an isolated spreadsheet metric. It will look at the nested causality of the entire organization, ensuring its recommendations help the whole human system progress, rather than just forcing a localized short-term win. Next up is Section 3, Model 2, Cosmological Emergence. Malik's second model, the cosmology of light, introduces this brilliant concept we can think of as a rule of 4. It proposes that form and meaning emerge universally through 4 core properties. Let's break them down. First, we have knowledge, which is all about information, pattern, and identity. Second is presence, meaning existence, embodiment, and localization. Third is power, covering action, force, and transformation. And finally, harmony, which represents relationship, balance, and coherence. This beautifully illustrates how literally everything, from cellular biology to the physics of light, is actually organized. And here's the crucial takeaway. Language itself belongs to nature. Therefore, language is governed by this exact same fourfold dynamic. Malik calls this a grammar of emergence. When an AI relies only on statistical correlations, just guessing the next word based on internet data, it's super superficial. But if we can teach AI this grammar of emergence, it can grasp the deep semantic themes of knowledge, presence, power, and harmony across any field. It completely moves from mimicking human text to actually understanding the underlying architecture of meaning. Which brings us to Section 4, Rewiring LLM Attention Mechanisms. Okay, this is where the explainer gets a bit technical, but it is profoundly exciting. Current large language models use transformer architectures with attention mechanisms, parameterized by queries, keys, and values. Basically, they calculate statistical relevance between words. But Malik and his co-researchers propose explicitly coding those four properties, knowledge, presence, power, and harmony, directly into these parameters. Think of it like teaching an AI underlying music theory, rather than just having it guess the next note by rote memorization. By doing this, we massively enhance the LLM's abstraction. The AI wouldn't just map words, it would detect invariant structural patterns. It could infer unstated implications and find deep analogies across entirely different scientific domains because it's actively attending to how meaning actually emerges. Let's dive into Section 5, Model 3, Quantum Reality. This introduces the QIQD framework that stands for the quaternary interpretation of quantum dynamics. The comparison here to classical computing is stark. Classical computing relies on GPUs running probabilistic algorithms, so when it's applied to material science, it's just simulating combining conventional atomic elements. QIQD, however, proposes an environment of quantum certainty. Using what's called a dialogic computer, the AI doesn't just guess chemical combinations anymore. It computes deterministically, directly, via fundamental properties. To make this concrete, use this simple analogy. It's literally like baking with flavors instead of ingredients. In conventional chemistry, you have to mix two physical ingredients, let's say an apple and cinnamon, hoping they bond chemically the right way. But QI2D proposes identifying the specific isolated property you want, like the flavor of superconductivity, and encoding that property directly into a computational substrate to simulate a completely new material. You're combining isolated properties, totally bypassing the physical constraints of traditional elemental chemistry. And that leads us to our final section, number 6, property-programmed physical reality. Let's look at how this all builds into the ultimate operational stack of the future. Step 1, natural language intention. A human tells the AI what new material function they need. Step 2, the LLM translates this intention into a constrained property program based on those fourfold rules of knowledge, presence, power, and harmony. Step 3, the dialogic computer runs a simulation ensuring the combination obeys the laws of physics and coherence. And finally, step 4, physical execution. A future QI, quantum computer, acts on the simulation to actually instantiate these properties into a real physical substrate. So the grand shift we are looking at as strategic leaders is this. Current generative AI computes about matter. It predicts, it models, it generates text or pictures, simulating reality. But future QIQD systems will compute into matter. They're going to use an AI-mediated interface to legally and predictably program entirely new physical forms right at the level of their fundamental properties. We are literally talking about moving from AI that merely represents the world to AI that creates the material world. We started today by observing that AI is entering an era of participation. It is going to participate in human transformation, in the emergence of meaning, and eventually in the quantum properties of reality itself. So I want to leave you with this final provocative thought. When computation inevitably moves from simply representing matter to actively programming matter, what will you build? Thank you so much for joining me for this explainer, and I really hope this deep dive into the architecture of becoming has sparked some incredible ideas for your future strategies.